Hello everyone. So my name is Changshu Chatterjee. I am a MTech student at IIT Madras. So today in this tutorial, I will try to show how to simply use a ML model such as a SVM or linear. You can also use linear regression, logistic regression, other models. After going through a bit of theory about them, so today I will simply show how to use the SVM and train it on the very famous iris dataset, and how to predict using a model, and what are the following syntaxes in collab. Okay, so you will also get a kind of idea how to use collab. Okay, so as you can see in the screen, first of all, I have opened collab. You can simply open a collab. No, there is no problems about that. You can go to collab Google, open collab. Okay, so now you can go to new notebook and create a particular notebook, and it will be very empty. You can just rename it whatever you want. Let's just wait until it opens. So yes, so you can click here, Control A, and you can rename it whatever you want, and you can simply write any code you want. So I have already developed the collab file or written the code in the collab file. The collab saves the Python file in .ipynb format, which is very useful to remember. You cannot just simply convert it into a run it into a Python editor. It will not simply work like that. You have to convert it into .ipynb if you are using collab, or similarly if you are using Jupyter notebook. So these are the following imports that we will be using. This is a very simple tutorial. Further difficult tutorials I will get into those in the next tutorials. I will try to make further more videos about those. For example, what are the basics behind SVM, what are the hyperparameters, and how hyperparameter tuning is done. But here we will just learn how to import from sklearn. Sklearn is a library where most of majority of the ML models are already present. You just need to import them. So first one is a Numpy. Numpy is a library for an array operating, or array operations. Numpy. Now, a lot of array operations can be done using this library. Then Pandas. Pandas is actually a data frame library which helps us to access or read CSV files. Initially, you will, majority of you guys, anyone watching my videos, will be working on CSV files, especially for ML models and prediction and all that. So Pandas will be very necessary. So as you will be using the iris dataset from the sklearn library itself, so you are using the import datasets. Now this is the test and split. We will come to that later on, why we need that and why it is important for any ML model. Now this is the SVM. It is present in the sklearn.svm library, and it is known as SVC. Now there are some metrics such as accuracy score, one of which I have used. There are several other metrics which are generally used, which you have to go through first in the theory of how SVM works, and then what happens when further hyperparameter tuning or different kinds of hyperparameter tuning is done, which kind of the scores are evaluation matrices, or scores are actually important, such as F1 score, precision recall, and everything. And this is the import for plotting, which we have not done in this IPNB file or code, let us say, but it might be necessary if you want to plot or visualize the data or the model how it is working. So first of all, this is a simple code where you have written df is equal to datasets and dot load. So we will be loading the corresponding iris dataset, and it will be present in the df. So if you print the df, you will see now the description is present that it is the iris dataset, iris pan dataset. Now this is the corresponding data. Now data contains actually the array, right? There are 4 features in this particular dataset, which you can see over here. There are 3 classes. As you can see in the corresponding data description, there are 3 classes which are present in the target names: Setosa, Versicolor, and Virginica. These are the 3 different classes. Now they are embedded or encoded as in the target array, which we call as the label of the dataset, as 0, corresponding ones, and corresponding 2s, right? And this is the X dataset, which contains values for 4 important features. There are 4 important features, as I already told. Right, now the 4 important features, as you can show, if you have the description, you can show that. Yes, the 4 important features, as you can see, is the sepal length, sepal width, petal length, and petal width, all in centimeters. So these are the values in centimeters, and this is the corresponding label for each of the value in the X, or what we call the data. So now, as the corresponding data is already present in a NumPy array format, we don't have to do anything. We just simply read it in X read it in the X variable, which you call it as the training data, call it as the data, right, or the feature set. And Y is the corresponding label, which is present as the data frame to target, that is this target array, or the array of the labels. Now we will use, as I mentioned previously in the inputs, that is the test and split package that is present in the model selection library of sklearn. We will use that to split the data in a stratified manner, so that there are equivalent splits with a test size of 0.3, that is 30% of the data will be split into X test, and correspondingly the levels will be present in the Y test, and 70% will be in X train, and corresponding the levels will be Y train. Now the major reason for doing stratified split is so that, as we already saw in the corresponding iris data set, if you can see, there are total of 50 samples per class, and total samples are 150. Now when we are splitting the corresponding data into X train and X test, we want a kind of equal split for every class, right? For example, if we say that there are 20 values from one of the target, for example for the level 0 there are 50 values. Now there are 20 values going to the X state. Similarly 20 values should go from the level 1, and similarly 20 values should go from the level 2 as well. Close values using, so that is the reason why you are using the stratified function, so that stratified split is done. Now it is very important in most of recent machine learning frameworks, so that equivalency of the classes is present and class imbalancing is not there, right? Now as you can see, you can print the shapes. You can see it is divided, training there are 105 corresponding data in the training, and the test there are 45 corresponding files, and as you can see it is 105 cross 4, as there are 4 features, and here also have 4 features, and label is just a one dimensional array, so there are no such second values, as you can already see. That is, it means it is a one dimensional array with 105 values. And here similarly, if you print y test dot shape, it will see 45 different values in a single one dimensional array. Now this is the important part when you are using any model, let us say from sklearn. So first of all, you can use model or any name as you want, and this is corresponding the function that you have to call to implement the SVM, right? And these are the hyperparameters which you can go through in the theory first, and they will come to know. Here I am using RBF kernel. Now what is a kernel? These all you need to go through in the theory first. I am just showing how to simply code or use AML model for your simple data sets, just syntax wise, right? Theory wise I will have more videos in for the future which will explain why I have used kernel as RBF and what is gamma, right? Now the next step in the syntax is model.fit, and with the values, that is the data and the corresponding level, which is extrain and white, right? So I am fitting the model, that is the SVM model, with the values, with the data extrain and the level white. Now as you can see in the next code line, there is ypred is equal to model.predict. Now this is also a predefined function that is present in the sklearn library as well. So I am using the model to predict on the X test. Now what here we are doing is we are passing the X test data, that is the 30% data for our case, which we have not used for training. As you can see, we have used only for a training X train and Y train, the corresponding levels, and we are passing the X test data and the corresponding numpy array that is generated as predicted array. For example, if we passed a simple one kind of feature vector, right? One feature vector with 4 features. Now if you predict it, it will correspondingly generate a single label. For example, it is generating a label 2. Similarly, for every value in the X test, it is generating a label corresponding to the X test, which is the Y pred. Now we can evaluate the model because we already have the Y test, that is the actual value. This is the predicted value Y pred, but the Y test that we have is the actual corresponding level for this X test. So you can use an accuracy score. This is the important metric that we are actually using, which will print the accuracy, right? We will use an accuracy score where the true value and the predicted value we will pass, and it will give us an accuracy of, here as you can see, it is giving us an accuracy of 97.7%, right? Now similarly, as you can show in the next line, I have shown how to predict for a single value. Now these kind of applications can be used for web applications using flasks and other things as well. So this is just a simple implementation of a SVM model on a iris dataset, which is very easy. We'll get into complex models, we'll get into CNNs. I'll make tutorials on how to implement LSTM, CNNs, CRNNs, and implement them in complex for complex problems. I have many models in my GitHub code which will be present, which is present in my website. You can check it out. You can go through that afterwards in my website. This video will also be uploaded in my website as well, right? So thank you everyone. Thank you for this. Now just before going, I can show you what these kernels actually do. For example, if I reduce the gamma value from 0.1 from 1 to 0.2, and now if I rerun the important part in collab is you can easily simply run every cell continuously one after the other using a shift enter, shift plus enter key, and you will simply run every cell, right? I replace shift enter. So similarly, if I do this with gamma 2, the accuracy remains the correspondingly same, but for some values the accuracy might actually change, right? For example, if I change the kernel to linear kernel, right? Now let us see what the accuracy get. What accuracy do we get? Yeah, so as you can see, the accuracy is 95.555, which can approximate to 95.6%, right? So the accuracy will change. So hyperparameter tuning, as you said, which is determining the correct or best hyperparameters for a particular model for a particular specific problem, is very important, which will make further tutorials on. Right? So thank you, and please do follow my projects on my website as well as GitHub. You can follow me on LinkedIn as well. Every detail is present in my website.